The last sections we're covering in Unit 2 actually go backwards to Chapter 5. We're looking at the unit circle, but what's great about this is that we've done most of this information already, so we can kind of skim through 5.1 pretty fast here. The unit circle does have an equation. If you remember the equation of a circle, we have x minus h squared, y minus k squared, but if it's centered at the origin, it's just x squared and y squared, and then it equals r squared, but if the unit circle has a radius of 1, 1 squared is 1. So the unit circle, again, does actually have its own equation. And so on number 1, we're just going to show that this point is on the unit circle. We've been discussing points like 1/2 root 3 over 2 and all that kind of stuff, but there are other points. There's infinitely many points on it. So to show this, I'm just going to plug in the x and y into the equation, and it should equal 1. So I'd have negative 5/7 squared plus 2 root 6 over 7 squared. Okay, well, negative 5/7 squared, I'd square the top and bottom, and that'd give me 25 over 49. The second part, be careful here. 2 root 6 squared, I have to square the 2, and, I have to square the root 6. I'm squaring both of those and then multiplying them together. So that would be 4 times 6, which is 24 over 49. And that gives me 49 over 49, which is 1. So basically we were just verifying, check, that point is on the unit circle. Now for number 2, A and B, we're going to find the missing coordinate. So we're going to use the equation of the unit circle. So 2/5 squared plus, I don't know the y coordinate, squared, equals 1. And I'm just going to solve this for y. So if I square 2/5, that would give me 4 over 25. So I'm going to have to subtract over 4 over 25. That'll get that out of there. And so that'll leave me with y squared equals 21 over 25, which when I square root that, technically I get a plus or minus for the y. This is where the quadrant comes into play. If I'm in quadrant 4, if I'm down here, it must be a negative y coordinate. So I'm going to use the negative version of it. And so it's going to be that my y coordinate is negative. Well, I take the square root of top and bottom on the fraction. I can't do anything with square root of 21, but square root of 25 is 5. There's my y coordinate. Similar logic on letter B, except this time I don't know my x. So 2/7 squared is 4 over 49. So I'd have to subtract over a 4 over 49. So I'd end up with x squared equals, if I do 1 minus 4 over 49, that'll give me 45 over 49. And again, when I square root, this is where I have to be aware of what quadrant I'm in. Since I'm in quadrant 1, I know my x coordinate is going to be positive, so I'm going to be taking the positive square root. The square root of 45, you can break that down. You can factor tree that down and get 3 root 5. The square root of 49 is 7, and again, it would be the positive because I'm in quadrant 1. So this is just showing that there are more points on the unit circle than just the ones that come from the 30, 60, 45, all that fun stuff that we've been doing throughout this unit. Letter C is basically the same type of problem. It's giving me the x coordinate. So that'll be squared. I don't know the y coordinate. Oops, y squared, excuse me. And it does say that P is below the x-axis. So the fact that the point is below the x-axis, that means my y coordinate is going to be negative. So when I get to that point, I'll be doing the negative of the square root. So root 5 squared is 5. So 5 over 25. So when I subtract over the 5 over 25, I'd end up with y squared equals 20 over 25. I would take the square root. And again, this time, since P is below the x-axis, that tells me that my y is going to be negative. Root 20, you can factor tree that down into 2 root 5. Square root of 25 is 5, and there we go. Now, where does this come into play for our trig stuff? This gives us another option for finding the trig functions if I'm given one of the functions. So don't worry about writing this down at first, this first part here, but the way we were doing this previously, which still works, it doesn't matter to me how you do it, is, all right, cosine is negative, tangent is positive. That tells me that I must be in quadrant 3. So I'd build a right triangle. And the fact that it gives me the cosine, that tells me the adjacent over hypotenuse. And then we could use Pythagorean theorem to find our missing side and find the other trig functions from there. That's how we did it earlier in this unit. Now we just have another option for this. So I can use the equation of the unit circle to solve this. So if it's giving me the cosine, remember the cosine is the x coordinate when I'm doing coordinates or points on the unit circle. Remember, it goes cosine followed by sine. So really it gave me the x coordinate. So I can do the exact same stuff I've been doing. And again, negative root 11 over 6 squared plus y squared equals 1. So that would give me 11 over 36. So when I subtract over 11 over 36, I'd end up with y squared equals 25 over 36. Ooh, getting some really bad writing here. When I square root that, remember I was in quadrant 3, the y coordinate would be negative down there. So y would be negative 5 over 6. Okay, how does that help me? Well, remember that is the sine. So the y coordinate is the value of the sine. So the sine of this t is negative 5/6. Having the sine and the cosine now, I can get everybody else. The cosecant is just the reciprocal of sine, so negative 6 over 5. I was already given the cosine, so I just need the secant, which would be the flip of the cosine, so negative 6 over root 11. And then to find tangent, remember that tangent is also thought of as sine over cosine. So make a little room here. If tangent is sine over cosine, well, I've got the sine, negative 5 over 6. If I divide by the cosine, that means I'm going to multiply by the reciprocal of that. So I'm going to multiply by 6 over root 11. Sixes would cancel, negatives go away. And so I get the tangent to be positive 5 over root 11, which makes the cotangent root 11 over 5. So again, whichever option you want, you can use the unit circle equation, x squared plus y squared equals 1, or you can draw a triangle. That's how we were doing it previously, was drawing a triangle. Does not matter. Whatever makes more sense to you. For number 4, we're using, again, that idea that the coordinates on the unit circle represent the cosine and the sine. If my angle is 3 pi over 2, okay, we should know by now that 3 pi over 2 is 270 degrees. Remember, if that's a unit circle, that gives me coordinates of 0, -1. And remember that those go cos, sine, for the x and the y. So the sine of the angle would be -1. The cosine of the angle would be 0. Tangent is sine over cosine. So that would be -1 over 0. Oops, can't do that. Tangent is undefined. Now, where students get messed up is on the reciprocals, the cosecant, secant, and cotangent. Remember, cosecant is the flip of sine. So think of sine as -1 over 1. If I flip that, it's still -1. This is where it gets a little funkier. The secant is the flip of cosine. Well, if cosine is 0, think of that as 0 over 1. If I flip that, I get division by 0, so the secant is undefined. And lastly, the cotangent is the flip of tangent. But how do I flip undefined? Well, remember, for tangent, when I was doing the tangent part, I did sine over cosine. So if I flip that, now I'm okay. 0 divided by -1, that's just 0. So basically, here's what I want you to notice on this. 0 and undefined would be considered reciprocals, if you will. 0 and undefined are reciprocals. So if I flip an undefined, it's 0. If I flip a 0, it's undefined. So that's basically a very shortened version of 5.1. Now we're going to look at a very shortened version of 5.2, which deals with even and odd functions. Now, you already did these back in algebra, but a little refresher. Basically, if plugging in a negative for every x doesn't change anything, if it makes the function stay exactly what it was, then that is called an even function. And so a quick example of an even function is x squared, because if I replace it with a -x, squaring it, I get right back to where I started. It did not change. And graphically, these have a symmetry over the y-axis. If you think about it, a parabola is symmetric over the y-axis. It's a mirror image. An odd function says that if I replace x with a negative, what comes out is the negative of the original function. So with the example here, x cubed is a very simple example of an odd function. If I replace it with a -x, that is saying -x cubed. I got the negative of the original function. And odd functions have an origin symmetry, which is a rotational symmetry. X cubed looks something like this, or drawing of it. But if I turn that 180 degrees, it's a mirror image of itself. So that's just a quick little review of what even and odd functions are. It turns out that the trig functions are even or odd. Actually, a lot of functions are neither of these, but all the trig functions satisfy one out of the other. So it turns out that the sine, the cosecant, so the sine and its reciprocal, the tangent and its reciprocal, cotangent, are all odd functions. So these are odd, and these are odd. Basically, putting in a negative for the variable, the negative comes out in front. Whereas cosine and secant, if you put in a negative for the variable, it doesn't change anything. You're right back to where you started. Cosine and secant are even functions. When we look at the graphs of sine and cosine in the next unit, we'll see this as well. We'll see graphically that, yeah, sine is an odd function, cosine is an even function. So on the last problems here, we're going to determine if these are even, odd, or neither. So here's the test. I replace the variable with negative of the variable. So if I did negative x to the fifth, tangent negative x. Let's see what happens to the negatives. That seems to be what matters with even and odd. Negative x to the fifth, that is just negative outside of it, x to the fifth. The negative doesn't go away. Well, tangent of negative x, according to my table, the negative comes out. And now if you notice, I have a negative times a negative, which is positive. I go right back to where I started. So this overall function, I got the exact same thing out that I started with. This overall function, x to the fifth tangent x, is even. Again, if you get the same thing back that you started with, it's even. For letter B, I've got an 8 in there with the x, but it's not really going to influence anything. Again, the test is replace the x's with negatives. So if I plug in a negative x there, that's going to be cosine negative 8x. Well, for the first part, a negative to an even power, that negative is just gone. And again, it doesn't matter that it's 8x, it's still negative of something. According to the cosine rule, since it's even, that negative just disappears. Doesn't really disappear, but we treat it as if it disappears. Again, I got out what I started with, exact same function, so this is even as well. I'm gonna bring these up so we can, there we go, see them and keep using this table. All right, again, the test is replace the variable with a negative. So this would be sine negative x minus cosine negative x. Okay. Sine is an odd function, therefore replacing it with a negative would bring the negative out. I still got a minus sign in between. Replacing cosine with a negative, though, doesn't do anything. The negative disappears. Okay, so here's the tricky one. I definitely did not get the exact same thing back because there's this pesky negative out in front. So it's not even. Is it odd though? Well, odd would mean that I'd get the negative of the original, but the negative of the original would have been negative sine plus cosine. I did not get that either. So this is neither even nor odd. And actually most functions are neither. We're just dealing with a lot of special cases right now. For letter D, same thing. Let's replace the variable with its negative and see what happens. All right, cosecant is an odd function, so the negative will come out. secant, however, is an even function, so the negative just disappears. This time, I didn't get the same thing, but I did get the negative of the original. If I put a negative out in front of this, it's not distributed because they're being multiplied. I do get the negative of the original function, so this is an odd function.